Hey guys, Dr. Brown here, and we're going to work through an area problem that the students here at TSU had just the other day. So I've already worked it out for you, so this will be a short video, but this deals with two functions, y equals ax and x equals ay. So the question is, what's the area between those two curves? And you can see, since we have y and x, let's go ahead and solve the other equation by dividing both sides by a. So now we have y equals x over a and y equals a times x. Okay? Well, we don't know what a is, but we can assume, let's say it's infinity. That makes this one really large. If a is infinity, in this one it approaches 0. So we can say that ax is larger than x over a. Obviously just makes sense. Okay, so f of x is greater than g of x. So our formulation then is a, or the area, is the integral from two arbitrary x values here. I'm calling them x sub 1 and x sub 2. Of f of x minus g of x dx. So now, we're plug in our lines that are in question. The area then is the integral from x1 to x2 of ax minus x over a. So that gives me then, if we integrate, ax squared over 2 minus x over 2, or excuse me, x squared over 2a. And that's from x1 to x2. So plugging in those values, we have a times x sub 2 squared over 2 minus x sub 2 squared over 2a, and then the same plugging in x sub 1. Now if I'm trying to subtract these, I need a common denominator, so I need to multiply by a. I'll let 2a be my common denominator, so I multiply this by a over a, and I get a squared, x sub 2 squared over 2a minus x sub 2 squared over 2a. And then do the same for this side of it, multiply this side by a over a, so that I can put those two together under a common denominator. So now I'm left with this. Okay, you can see that I can factor out an x sub 2 here, it's in both sides, and an x sub 1 there, which is what I've done up here at the top of the board. Factored out that x sub 2, and that left me with a squared minus 1 over 2a, and factored out the x sub 1 squared, and that left me with a squared minus 1. Hey, how about that? Okay. So now, what do we have? We can factor out a squared minus 1 times x sub 2 squared minus x sub 1 squared all over 2a. And that would be the area that the teacher was looking for, that formulation. Now, I might add, if you were to take, and you can try this, let a be 3, for example. If you run through the integration, you'll get 8 over 6 or 4 over 3. And if you let a equal here, now this is integrating from 0 to 1, you'll get the same answer. But also, something that's interesting, if I let ax equal x over a, which we do, what's the point of intersection of those two curves? You'll find, if I multiply both sides by a, I have a squared, x equals x. Divide both sides by x, I have a squared equals 1, so a equals plus or minus 1. So that's when those two curves intersect. So if a is the same value in each one of these, so let's say it's 1. 1 times x is x, and x over 1 is x also, so y equals x in that case. But if I'm integrating the area when the two lines are the same, the area would be 0. And this will confirm that. Let's let x equal 1. 1 minus 1 is 0. 0 times anything is 0. So my area would be 0 when a equals 1. Negative 1 squared is 1. 1 minus 1 is 0. Again, the area is 0. So that formula works out, and that's, I think, what the teacher was looking for. Why are we doing this? Together we're trying to build a better tomorrow and do that through math. Keep studying, guys. Keep setting yourself up for success rather than failure, okay? Study, study, study. All right, that's all for now. Talk to you next time. Thanks.